All right, guys. So today we're going to talk about looking at the difference between using the quadratic formula and factoring, and how we can actually use pretty much either one whenever we want, and then we can also use graphing whenever we want to as well. Okay, so one thing I want to touch on real quick is using Desmos with our graphing. Okay, so we can use what we have here in our notes as our example. So if we look here at this first problem, we have x squared minus 9x plus 14 equals 0. So if I just ask you a problem like this on a test or a quiz, or if you see any sort of thing where it says solve, right? So if this tells us to solve, I know that it's going to look a little weird here, but if it says to solve with this, I don't care which method you use. I don't. You can use graphing, you can use factoring, or the quadratic formula. And we're going to do all three for this same problem. You're going to see how no matter what, we can get the same answer. All right, so if I want to graph this, so I'm going to type in x squared and then minus 9x and plus 14. Now, this is how we can graph it. We can see our quadratic. I can find where my solutions are at positive 2 and positive 7. Now, if you went ahead and you actually did type in the entire equation, the equals 0, it's no longer going to give you your quadratic parabola. It's just going to give you where your solutions are. So I want you to understand that when we type this in as it looks, Desmos does allow us in order to find where the solutions are in this way. Okay, so now we know the solutions are at positive 2 and positive 7. Now if we look here, if I want to solve this by factoring, I can see I have 3 terms on the left. My leading coefficient is 1. That tells me it's a basic trinomial. And the 2 numbers that multiply to 14 that add to negative 9 are negative 2 and positive 7. Okay, that allows me to factor this this trinomial on the left-hand side into x minus 2 and x minus 7. That's a negative 7 as well, sorry. Okay, so x minus 2 and x minus 7. And if you think back to what we had talked about in the second unit with our factoring and our solving here, is that once we have our factors, we set them both equal to 0. X minus 2 equals 0 and x minus 7 is equal to 0. Okay, and from here we get the opposite. We get, again, x equals positive 2 and x equals positive 7, which is exactly what it showed us over here in Desmos. Okay, now I'm going to show you the exact same problem, but now we're going to do it with the quadratic formula. All right, so the first thing with the quadratic formula is making sure it's in standard form. Have it set equal to 0 on the right, which it is. And make sure that it's in descending order, x squared, x, and then our constant. Okay, our value of a, as we know, is the value in front of the x squared, that's 1. B, that's the value in front of the x, the negative 9. And c is the constant 14. All right, so now we can use our quadratic formula. We can get x equals, the first thing is negative b, the opposite of b. B is already negative 9, so that gives me a positive 9. Then we have a plus or a minus sign. Then we have a square root. And the first thing inside the square root is b squared, so I'm going to put in parentheses my negative 9 squared. Then we have a minus 4 times our value of a1 times our value of c14. Okay, and we divide all of that by 2 times my value of a, which is 1. All right, once you have your quadratic formula with all of your a's, your b's, and your c's put in, we are going to reduce inside the square root. So the 9 stays the same, the plus and minus, and now I've got my square root. Negative 9 squared gives me positive 81. And then negative 4 times 14. 14 times 2 is 28, times 2 is 56. So we are going to subtract 56 from this. And then we're going to divide all of that by 2. All right, I'm going to reduce that even more. I have 9 plus or minus the square root. 81 minus 56 is 25. Divided by 2. And now we know that the square root of 25 is just 5. So we have 9 plus or minus 5, all divided by 2. So we have two solutions here. We have 9 plus 5 over 2 and 9 minus 5. I'll scroll down here, divided by 2. 9 plus 5 gives us 14, divided by 2 gives us 7, which again, we already knew. And 9 minus the 5 gives us 4, divided by 2 gives us 2. All right, so again, that's 3 separate ways, graphing, factoring, and the quadratic formula to find the same answer, okay? All right, let's take a look at another problem here. Let's look at number 3. All right, so number 3, first thing, no matter what, and I would always suggest this, is get it in standard form. And right away, this is not in standard form because it's not set equal to 0. And on the right-hand side, I have a positive 5x. Now, if you have a positive number, the only thing you can do to move it is subtract it on both sides. And you have to subtract it on both sides or else it doesn't work. I can't combine the x's because this is an x squared and this is an x. So we have x squared minus a 5x, and then we have the positive 2. And these 5x's cancel out to leave us with a 0. So now we have our standard form of x squared minus 5x plus 2. So if we check it in Desmos here, if we do x squared minus 5x plus 2, we can see our solutions are at 0.438 and 4.562. Okay, so that's what we're going to try and find. Now, obviously, this is not a problem that we can factor because there's no two numbers that multiply to 2 that add to negative 5. So I'm not even going to try to factor it because it won't work. So the only thing I can do here is do my quadratic formula. Use A is 1, B is negative 5, and C is positive 2. Okay, I'm going to extend this down a little bit. All right, so we're going to do our quadratic formula. We have x equals, the first thing is negative b. Again, b is already negative, so we do positive 5 plus or minus the square root. And then the first thing is b squared, so that's negative 5 squared minus 4 times the value of a is 1 times the value of c is 2. And I'm dividing that all by 2 times a. So I'm going to reduce. We have 5 plus or minus the square root. Negative 5 squared is positive 25. Negative 4 times 1 times 2 is negative 8. All divided by 2. Okay, so we're going to do the same thing as what we just did on the last problem. I'm going to reduce inside. So we have x equals 5 plus or minus the square root. 25 minus 8 is 17 divided by 2. Now, in the other problem, we had the square root of 25. Okay, if we take a look here, we had square root of 25, so that reduced to 5. But here we have the square root of 17. Now, 17 is not on our perfect square list, so we can't change this. We can't reduce it. So that's where our calculator is going to come in handy. And we can actually use Desmos for this. So remember, I can type this all in. I can do 5 plus, and then find the square root button here. the square root of 17 in parentheses here, and then divide that all by 2. And that gives us the 4. So, because remember, we have two answers here. We have 5 plus square root 17 over 2, and 5 minus square root 17 over 2. So when we add them together, that's what we have here, the 4.56, and if I subtract, so I can just change this to a subtraction sign, that gives me the 0.438 or the 0.44. 0.44. And again, if I check in Desmos on the graph, the 0.438 and the 4.562, which is exactly what we had. So in any given problem on a test or a quiz, if I ask you to just solve, you can use any method you want. Graph it. Use the quadratic formula. It does not matter. Okay? So I want to set up a couple of these with you, just go through these real quick, and we'll talk about Desmos, and we'll make sure that we're doing this the right way. So if we look at number 5, I have an x squared and a 64 on the right side. They're both positive, so I have to subtract them both onto the other side. So I'm going to subtract the x squared from the 10x squared. That leaves me with just 9x squared. And I'm subtracting that 64 over as well. And now I'm set equal to 0 because these cancel. All right, this problem actually you can solve 3 different ways. You can solve it by graphing, by factoring, and by the quadratic formula. Okay, so if we use our graph here, we do 9x raised to the second power minus 64. That gives us at negative 2.667 and positive 2.667. Okay. You can do this by factoring, by noticing this is difference of squares. What am I squaring? 3x. What am I squaring? An 8. So we have 3x plus 8, 3x minus 8. Or we could use the quadratic formula and let a be 9, b is equal to 0, and c is equal to negative 64. Okay, b is equal to 0 because there's no x term. So let's do this one real quick with the quadratic formula, and that'll be it for this. And then I'll just take a look at those other ones real quick. So we've got x equals, the first thing is negative b. Well, b is 0, so there's no negative to go along with that. Plus or minus the square root. Inside the square root is b squared. That's 0 squared. That doesn't change. Minus 4 times my value of a is 9 times my value of c is negative 64. And it's all being divided by 2 times 9, which is 2 times a. Okay, so we're going to reduce inside. We have 0 plus or minus the square root. 0 squared is just 0. I do not have to write it. Now, if you don't know what this is off the top of your head, which I'd be hard pressed to know that you did, we're going to do negative 4 times 9 and multiply that by negative 64. And we can see right here that's positive 2,304. So we have 2,304 underneath. That's a 0 there. There we go. And all divided by 18. Now we can check to see if 2,304 is a perfect square by doing the square root of 2,304, and it gives us 48. So we can reduce this to 0 plus or minus 48 over 18. So we have two answers here. The first x is 0 plus 48 over 18. And the second one is 0 minus 48 over 18. Okay, so we have 0 plus 48, and then we can divide that entire, if I put it in parentheses, I can divide that entire thing by 18. That gives us the 2.67. So 2.67. And then I can do 0 minus 48, put it in parentheses, and divide that by 18, and get the negative 2.67. Okay, and again, by looking at our graph here, negative 2.667 or negative 2.67 and positive 2.67, which is exactly what we got in our quadratic formula. Okay. If we take a look here at number six, it's in standard form already, so you can solve it any method that you want. I do not believe this one is factorable. If we check these real quick, let's graph it and see. If we get a really weird answer here, then usually it's not factorable. So, yeah, in this one right here, you can see that there's actually no solution to it. You can see it never actually crosses the x-axis, or it doesn't touch it. And let's see that real quick. So A is 3, B is 4, and C is 2. So if we do this in quadratic formula, we get negative B or negative 4 plus or minus the square root of 4 squared minus 4 times 3 times 2, all divided by 2 times 3. And we know we have no solution when the value underneath the square root ends up being negative. So if we reduce this here, we have negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times 3 times 2 is negative 24. And right there we can see why it's not going to work, because 16 minus 24 gives us a negative 8 here, and that's the reason why it won't work. Okay, so we can say that there is no solution to this problem. All right, so use this to help you out again. On a test, on a quiz, use Desmos in order to help you figure out where your solutions are, where your vertex is, where your axis of symmetry is. Use this as your advantage.